Not that far away from the planet, generally speaking, researchers have discovered a brand new planet called Proxima b. Stargazers, as of late, uncovered the most keen picture ever captured of Proxima b using the notable James Webb Space Telescope. This planet orbits the star that is closest to our Sun, and the wonderful image offers a remarkable look into a world outside our nearby planetary group, raising questions and excitement among researchers worldwide. But how did this telescope accomplish such an achievement? Might this image open up a window into a place that could have conditions appropriate for life? At last, what does this new discovery mean for how we understand exoplanets and the vast extraterrestrial universe? Join us as we explore the newly uncovered clear image of Proxima b, observed by the James Webb Telescope. A strange planet, Proxima Centauri b, sits within the vastness of space around its star, 4.2 light-years away from Earth. The first look at the clearest image of Proxima b has captured our imagination, raising questions about its likeness to our own planet. Might it be likened to Earth, with its abundant seas and life? Adding to the intrigue, Proxima Centauri isn't alone in its journey. It shares an orbit with another sizable planet, Proxima Centauri c. Proxima Centauri b gets about the same energy from its star as Earth does from the Sun, causing researchers to be curious about whether this distant planet could have water, or even support life. As we explore the endlessness of space, we encounter various exoplanets orbiting stars other than our Sun. Among the bewildering 206 trillion stars scattered across the universe, these opportunities for discovery seem limitless. Some of these planets even wander freely through space, like enormous migrants. Proxima Centauri b stands out as a unique puzzle in this extensive display of celestial bodies. Its year is surprisingly short, lasting just 11.7 Earth days, and it orbits its star about 20 times closer than Earth does to the Sun. As a result, one side of the planet is constantly washed in sunlight, while the other remains in endless darkness, adding to the strange and possibly alien nature of this world. Proxima b was initially discovered using the radial velocity method, an Earth-shattering procedure in exoplanet detection. This method relies on observing the subtle movements of a star caused by the gravitational pull of an orbiting planet. As the planet orbits, it creates a tiny but discernible motion, causing the star to change its orbit slightly. Experts detect this development by carefully studying changes in the star's spectral lines, a phenomenon called the Doppler shift. For Proxima b, these small changes in the star spectrum revealed the presence of this distant world, showcasing the radial velocity method's effectiveness in uncovering planets outside our solar system. Recognizing Proxima b was a significant milestone, as it confirmed the existence of an exoplanet within the habitable zone of the star closest to our own Sun. This discovery sparked immense interest from specialists and space enthusiasts alike. They are eager to explore the mysteries Proxima b may hold and what it could mean for our understanding of the universe, and the potential for life beyond Earth. Proxima Centauri b is, without a doubt, an astronomical marvel worth marveling at. Picture 3. Canopus, Regulus, and other celestial companions of Proxima Centauri moving across the vastness of space, forming the closest star system to our own. As we look into the night sky, Canopus and Regulus combine into a brilliant guide, shining together in the course constellation. These stars rank among the most brilliant, stunning us with their splendor at a peak magnitude of 0.27. However, it's the modest Proxima that holds an intriguing secret. Also known as Alpha Centauri c, this red dwarf belongs to the M-type class and is only 0.21 light-years from its brighter companions. To put it in perspective, that's multiple times farther than the distance between Earth and the Sun. Its name, Proxima Centauri, Latin for nearest star, emphasizes its position as our closest celestial neighbor. Back in 1915, Scottish cosmologist Robert Thorburn Innes revealed this divine gem to the world. Despite its proximity, Proxima Centauri is difficult to see with the naked eye, with an apparent magnitude of 11.13. A great distance beyond the natural visibility limit of 6.5. Nonetheless, it's a notable achievement in its own right. Red dwarf stars like Proxima Centauri are powerful energy sources, effectively producing energy through strong internal convection processes. This star will maintain its status as the primary star of the system for another 4 trillion years, exhibiting a lasting brilliance that spans the ages. However, the concept of habitability around Proxima Centauri comes with its fair share of challenges. Being a flare star, Proxima Centauri experiences sudden and intense eruptions of energy. Its lower mass means that any habitable zone, where life-friendly conditions may exist, is significantly closer to the star than the Sun's habitable zone. Enter Proxima b, a nearby planet within that zone, at a distance similar to Earth's orbit around the Sun. But appearances can be deceiving. Proxima b faces intense ultraviolet radiation, many times more powerful than what reaches Earth. This extreme radiation poses a threat even to hydrogen atoms, endangering the stability of essential elements like nitrogen and oxygen. Furthermore, simply occupying the Goldilocks zone does not guarantee a sustainable environment for life. Proxima b may lack the vital atmosphere necessary to regulate climate and sustain surface water. Without the protective shield of a strong atmosphere, any potential life forms would be exposed to the harshness of space, significantly reducing the chances of life as we know it. Still, the quest to uncover the secrets of Proxima b remains a significant driver in space exploration. Among the tools powering this search, the James Webb Space Telescope stands out. Launched at the end of 2021 after numerous delays, this cutting-edge telescope holds the promise of answering one of the most tantalizing questions in cosmology. Does life exist on Proxima b? The path to uncovering the truth is far from straightforward. The James Webb Telescope underwent substantial adjustments to ensure the accuracy of its images. As per a distinguished theoretical physicist at Harvard, Proxima b requires a nuanced approach. Situated inside the habitable zone of its star, the planet has the potential to absorb and emit life-sustaining infrared radiation, making it detectable by the James Webb Space Telescope. This advanced instrument can capture faint light from the planet's surface, supporting researchers in their search for signs of water or a viable environment. The crucial question of the presence of water on Proxima b plays an important part in understanding this nearby exoplanet. The presence of water substantially affects the potential for life as we understand it. Water, a fundamental component for life on Earth, if discovered on Proxima b, would greatly increase the likelihood of the planet being habitable, or at the very least able to support some form of life. Proxima b, located within the habitable zone of its star, receives the same amount of energy from its Sun as Earth receives from our own. However, because of how close it is to its red dwarf star, the planet is confronted by intense stellar phenomena, such as magnetic activity and radiation. Stability could be threatened by these factors, particularly any potential atmosphere. Furthermore, the presence of liquid water is still under investigation, currently challenging scientific models. The use of simulations is key to exploring different scenarios for Proxima's surroundings and the possibility of water reserves. Some hypotheses propose the existence of vast oceans on the planet, whereas others contend that any water may be encased in ice or submerged beneath the planet's surface. Clear identification of water on Proxima b presents an imposing challenge, requiring advanced telescope technology and specific atmospheric conditions. As our tools for observation continue to advance, the mystery surrounding the atmosphere of Proxima b and its potential water reserves is expected to unfold, bringing us truly closer to understanding the nature of this enthralling exoplanet. But the presence of an atmosphere alone doesn't guarantee Proxima b's habitability. Adam Turner, an astrophysicist at Princeton University, cautions against making assumptions based solely on atmospheric presence. He warns that the planet may resemble Venus, with a thick, choking atmosphere and extreme heat, rendering it unsuitable for life. As of right now, we call it Proxima b. Beyond being just another distant exoplanet, it emerges as a fascinating neighbor within our cosmic backyard, tantalizing us with the possibility of life-sustaining conditions. Its proximity to Earth makes it an attractive target for future space missions, sparking the interest of cosmologists and space enthusiasts alike. Although direct travel to Proxima b remains beyond our current technological capabilities, it possesses a strategic position in relation to potential interstellar missions. The challenges inherent in reaching Proxima b are indeed vast. Using existing spacecraft technology, exemplified by Voyager 2, the journey would require an astounding 73,000 years. However, the spirit of human creativity and innovation drives space exploration. In the future, possible solutions such as solar sails, ultra-thin sails that harness radiation pressure, could revolutionize space travel, pushing spacecraft at remarkable speeds and possibly reaching the Proxima Centauri system, where Proxima b resides, in just 20 years. This technological leap brings the dream of exploring an Earth-like exoplanet within our lifetime tantalizingly close to reality. The discovery of Proxima b has reignited humankind's curiosity about the universe, instilling a renewed sense of hope and fascination. It stands as a testament to our relentless desire to venture into the unknown, discover new worlds, and ponder the possibility of life beyond our home planet. While the James Webb Space Telescope represents a marvel in contemporary astronomy, it is not without its limits. Despite its extraordinary ability to observe celestial objects and shed light on the potential for life on exoplanets like Proxima b, it confronts difficulties in determining the presence of atmospheres and identifying conditions favorable to life. Proxima b and its similarities to Venus serve as a stark reminder. An atmosphere alone does not guarantee habitability. Nonetheless, the telescope's exceptional ability to detect even the tiniest indications of life, such as bright orbital mirrors or artificial developments, demonstrates its vast potential. The universe, with its vastness and mystery, holds within it a surprising number of planets eager to share their secrets. These celestial bodies, known as exoplanets, orbit stars far beyond the reaches of our solar system, displaying an amazing variety in terms of their sizes and compositions. Some mirror the giant gas planets like Jupiter and Saturn, while others resemble our own Earth. Gas giants, perhaps the most enchanting class of exoplanets, captivate cosmologists worldwide. These planets, similar in structure to Jupiter and Saturn, often surpass them in sheer size. Referred to as super-Jupiters, they loom so massively that they render Jupiter, the largest planet in our solar system, small by comparison. Alongside these immense entities reside the hot Jupiters, gas giants orbiting perilously close to their host stars, exposed to temperatures capable of melting metals. Investigating the characteristics of such planets reveals a world on fire, characterized by violent storms and scorching heat. However, the category of exoplanets is diverse, extending far beyond these giants. Exoplanets in the Neptune C class, with sizes comparable to Neptune and Uranus, are among them. Some, dubbed hot Neptunes, reside closer to their host stars than their larger relatives. Encased in atmospheres that remain enigmatic, they challenge our understanding. The quest to understand distant exoplanets like Proxima b has been advanced by cutting-edge technologies that expand our knowledge of the universe. As the field of exoplanet discovery continues to grow, new techniques, like the transit method, by which astronomers study the slight dimming of a star's light as a planet moves past it, have revolutionized our ability to detect and investigate planets beyond our solar system. This method has revealed thousands of exoplanets, many of which exist in their stars' habitable zones, where liquids might thrive under the right conditions. Water is essential to these discoveries, fueling the imagination and helping to address one of the most important questions in science. Are we alone in the universe? Alongside the discovery of planets like Proxima b, astronomers are constantly fine-tuning their biosignature searches, seeking indicators that may hint at the existence of life on other worlds. By studying the environments of exoplanets, scientists can identify gases such as oxygen, methane, and carbon dioxide, which are associated with biological processes. The James Webb Space Telescope, with its powerful infrared capabilities, is anticipated to be crucial to this field. It enables the detection of these gases even on planets a light year away. If scientists can confirm the presence of biomarkers in an exoplanet's atmosphere, it would provide convincing evidence that life exists elsewhere in the universe.